So this starts our discussion on transition elements. But before we discuss transition elements, because what we used to call transition elements, or what you have been used to calling them, are in fact D block elements. Now that we know all the blocks in the periodic table, we are really going to be talking about first D block elements. Now the periodic table has S blocks, P blocks, D blocks, and F blocks. And the S block is, you must remember it as being groups 1 and 2. We studied this in the AS. P block is from groups 13 to 18. And the D block of elements is literally from groups 3 to 12 now. Earlier, they were the guys between groups 2 and group 3. Now, group 3 is renamed group 13. And these vertical columns of the D block are given group numbers. They start from 3 and they go to 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And the elements that are between the P block and the S block, the P block and the S block, are referred to as the D block of elements. The ones that you've been calling transition elements since IGCSE O levels. Now, why are they in the D block? That's we already should know that. The fact that the same reason why elements are in the S block and the elements are in the P block. These elements are in the S block because their highest energy electron, also known as the outermost electron, occupies an S orbital. Like sodium was 3s1, magnesium 3s2. Similarly, in the P block, the highest energy electron occupies a P orbital. So, or the outermost electron. So, why are these the D block? Especially, I can give you an example from the first row. And these guys are D block because their highest energy electron, or the outermost electron, occupies a D orbital. These guys are the ones that start filling up from 3d1 to 3d10. If you remember the periodic table, okay, these guys were 1s1, 1s2, 2s1, 2s2, 2p1, all the way to 2p6, 3s1, 3s2, then 3p1 all the way to 3p6. And after 3p6, you don't fill out the 3d, you fill out the 4s. So 4s1, 4s2, and now you fill the 3d. So if you remember, calcium was 4s2, and then scandium, therefore the guy right after calcium would be 3d1, 4s2. Now let me show you the configurations just to jog your memory about the electrons. So the configuration of electrons in these D block elements, starting from scandium, that's the guy right after calcium. And if I were to write calcium here, it would be Ar and nothing in the 3D and only 2 in the 4s. 2s. 2 in the 4s. Then scandium, you fill out 1 in the 3D, then 2, then 3. And chromium, if you remember, was supposed to be 4, but that 4s jumps to the 3D, becomes a stable 3d5 4s1. Then it's 3d6, 3d5 4s2, 3d6, 3d7. They start pairing up. 3d8. Remember, initially they fill up individually and then they pair up. 3d8. Then copper is supposed to be 3d9 4s2, but we found it to be 3d10 4s1, is because the 4s electron has been promoted to the 3d to make that stable. And then zinc becomes 3d10 4s2 again. And after zinc, the whatever elements that comes after zinc, I think is gallium. Now gallium would be all of this, Ar, 3d10, 4s2, and then it'll fill out the 4p1 then. So from scandium to zinc, the electrons are going from 3d1 to 3d10. And this is the electronic configuration of the first row of the D block of elements. Yeah. And you should remember that the 4s fills before the 3d. Yeah. Now the next thing we're going to look at is the configuration, or the electronic configuration of ion of the D block elements. We look at them at AS, but just to make sure that we all know how it's done, we're going to take a look at it in A2 also. So let's use iron as an example. Now iron is Fe, and it's got 26 proton number, which means you got 26 electrons. 18 according to the argon configuration, that's 3p6, then 19 and 20 in the 4s, and then 6 more in the 3d. So the 4s does fill first and then the 3d fills up. But once iron decides to make, or iron has to make a 2 plus ion, it's not the 3d that loses electrons, even though that was filled at the end. It's once it's filled, the 4s loses electron before the 3d. That's the game for all transition elements. So Fe2 plus is not going to be, it's literally not going to be Ar 3d 4s2, even though the 4s filled before and then the 3d filled. So the 3d was the last guy that fills. It's not the first guy that loses electrons, unlike all other orbitals. Once filled, it's the 4s that loses. So it isn't this. Fe2 plus would first have to lose all of the 4s. And so in this case, 2 plus means losing 2 from the 4s. So it becomes 3d6 from 3d6 4s2. Now, if you wanted to make Fe3 plus, yes, you'd have to first lose the 2 from 4s and then 1 from 3d. So Fe3 plus would be 3d5. And this is stuff done before an AS. It's just, I'm just repeating it here, making sure that you all remember this, because this is stuff needed for, and you are asked about the configuration of d block ions. So if I show you the electron box diagrams of these three, iron 2, iron 3 plus, what do the 3d and 3d5 look like? It would be like this. So if iron is 3d6 4s2, where one of the orbitals has electrons that are paired up, when iron 2 is formed, 2 of the 4s are lost, the paired ones are lost. So it becomes 3d6. And when it becomes 3d5, then it's going to lose the paired electrons first before it loses the unpaired. So this one isn't lost to make 3d to make Fe3 plus, is the paired one that's lost. And that's what you got to keep in mind. Another pretty popular element, or one that shows variable oxidation states, is manganese. And let me show you its configuration of some of its ions. Now, if we talk about the electronic structures of manganese, remember the element itself has a proton number of 27. So its configuration for the atom, for the element, is Ar 3d5 4s2. And this is the guy dead center, I'd say, in the d block row. And because its d orbital is half full, it's a special guy. And so this is the configuration of manganese element, the atom of the element, 3d5 4s2. So when it becomes a 2 plus ion, it loses the 4s2. Then it becomes a 3 plus ion, it loses the 4s2, and it loses now the 3d5's 1 electron. And it is known to make even more oxidation states, but it can lose more electrons also. All right. Now let's look at an example. Let's see, this is the max you'll be asked in the exam to do. So I've taken this from your, I think one of the past papers would look like this, but really it's there. It's very simple. The stuff like trying to complete the electronic configuration for nickel and the nickel 2 plus ion. So if you remember the periodic table, nickel's proton number is 28. So nickel's configuration is literally Ar is 18. Then what you do is you fill out 2 electrons in the 4s. That's literally how much? 20. Then 21, 22, 23, 24, 25, 26, 27, 28. So this is what you make. Yeah. So this is 3d8 4s2. So for the 2 plus would just be 3d8. So you'll just have 3d8 and not 4s2. Yeah, pretty simple. All right. The other thing you could be asked is to find the number of unpaired electrons in elements, atoms, or ions. So here in nickel 2 plus ion, it has how many unpaired electrons? This one 1 and 2. So this fellow has 2 unpaired electrons. The others in the D are paired, and the ones below it are also paired. And that's something else that you could be asked about. The pairing of 3d electrons and the 4s electrons. I'll show you an example for that from a skill check also. This is in one of the skill checks in your notes also, but it's pretty simple to do. Complete the table to show the number of unpaired electrons in the 3d and the 4s orbitals of each of these isolated gaseous atoms. Now, you'll have to write the configuration first. So if I were to figure out what's chromium, chromium was Ar, which is paired, and 3D 5 4s1. Manganese is Ar 3D 5 4s2. And iron, if you remember, was Ar 3D 6 4s2. So this guy has all 5 in the d orbital unpaired, and even its 4s is unpaired. In manganese, the 4s electrons, there's only one orbital to 0 unpaired, but in the 5 and the 3d orbitals are unpaired. In iron, it's 4s2 3d6, so these are paired, so 0. And in the 6 electrons, 2 of them are paired, so it's 4 which are unpaired. Now this is some basic introduction to electronic configuration of elements from d block and transition elements. All right.